Good morning, class. Here's exam 4, review chapter 4, application of differentiation, chapter 5, integrals, 6.1, areas between curves, and we are finishing it up with the rest of section 5.5, the substitution rule, and 6.1, areas between curves. So we discussed the substitution. The idea behind the substitution is to find a function and its derivative in essence. So anytime ln x is involved, that is the choice of u. So what is the derivative of ln x? 1 over x dx or dx over x. And I'm going to write both because I want you to be exposed to both formats. And so having said that, I'm going to rewrite this so it becomes clear what we are dealing with. So this is ln x to the second power, and then 1 over x dx. This format or that format makes no difference. Therefore, we recognize this as u squared, this one as du. And that follows the power rule, 1/3 u cubed plus a constant. You replace the u with ln x. Please don't mix up with ln of x cubed. This is ln x times ln x 3 times, so don't mix them up. We are dealing with a fractional format, and recall I said if you have a fractional format, and of course this is not a rational function, the top and the bottom must be polynomials. The methodology is similar. Number one, can I simplify? If I can, I must put it in its lowest term. The second one, if I can't, most of the time, the denominator is the choice of u. And notice, what is the derivative of the bottom? E to the power of x is itself. E to the power minus x is minus e to the power minus x. So the top is the derivative of the bottom. So if u is the denominator, then du is the numerator times dx. And again, as always, remember, dx belongs to the numerator. So we are looking at the integral of du over u, which is again natural log. And you replace the u, you get natural log of e to the power of x plus e to the power minus x plus a constant. One thing I want to add is that we always put this in absolute value. However, if you know this is positive, you can take it out. And by the way, e to the power of x plus e to the power minus x is positive. Think about the range of e to the power of x as well as e to the power minus x. All right. Now, the integral of 3 to 4x squared of 25 minus x squared. So we are looking at a definite integral, a number, and we need to use substitution. So this is a polynomial, this is a polynomial under the radical. So the more complicated one, in this case, 25 minus x squared is a choice of u. If you differentiate, you get negative 2x. Therefore, du is negative 2x dx. We are going to rewrite this by moving the x next to dx. And as I mentioned, if a number is missing, you can throw in the number. You can only do that with the number and undo it with its reciprocal. The reciprocal of negative 2 is negative 1/2. It's important to know the product of the two numbers must be 1. You can't do that with a variable. And so this is negative 1/2, the square root of u du, and I'm not writing the limits. Why not? Because the original limits pertain to the original variable x, not u. So what are the new limits? We're going to discuss that in a moment. So let's rewrite this as u to the power of 1/2. And the reason we do that, so we can use the power rule on that. So this remains. This is 1 over 1/2 plus 1 u to the power of 1/2 plus 1. We've done it several times. 1/2 plus 1 is 3/2. This is 2/3. The product of these two is negative 1/3. And again, notice I don't have the limits yet. I can always go back to the original variable, namely x, and I'm going to replace the u with 25 minus x squared, and I use the original limits. You can always do that. However, it's normally easier to go with the new limits, with the new variable and new limits. So if I plug in 3 here, I get 9. So 25 minus 9 is 16. So the new lower limit is 16. If I plug in 4 here, 4 squared is 16. So 25 minus 16 is 9. So those are the new limits. So let's plug in 9 and let's plug in 16 and subtract one from the other. This to evaluate 9 to the power of 3 halves means square root of 9. Cubed, which is 3 cubed, which is 27. 16 to the power of 3 halves is square root of 16. Or cubed 64. 27 minus 64 is minus 37. With negative 1/3, the product is positive 37/3. A quick recap. You can always do the substitution, finish the job, go back to the original variable and original limits. Or plug in the lower limit into u and evaluate the u. Plug in the upper limit and evaluate the u, and those are the new limits for the new variable, namely u. ln of x plus 1 over x plus 1 dx. I'm going to integrate this from 0 to 1, and we have to do by substitution. So when ln is involved, that is the choice of u. So u is ln of x plus 1. Its derivative is 1 over x plus 1. Therefore, du is 1 over x plus 1 dx. Because the derivative of the parenthesis is 1, doesn't do anything. Okay, everybody. So we are going to rewrite this. So again, it becomes clear as to what we have. So what we are dealing with here is u du. And again, I'm not going to write the limits yet. I can go back to the original when I'm done, because this is half of u squared, and that's half of natural log of x plus 1 quantity squared from 0 to 1. Or let's figure out the new limits. So if I plug in 0 here, I get ln 1. If I put 1 here, I get ln 2. And of course, ln 1 is 0. So you plug in this one, you get half of ln 2 quantity squared. This one is 0, doesn't do anything. And again, it's ln 2 to the second power, means ln 2 times ln 2. The integral of negative 2 to 2 x to the power of 6 plus 1 dx. When the function has a symmetry, then it becomes easier to calculate its integral. So integral of symmetric functions, f is continuous in the given interval that we are interested in, from minus a to a. So if they are opposite of each other. F is odd, f of minus x equals minus f of x, the integral of minus a to a f of x dx equal to 0. And you can even see from the graph. If it's symmetric with respect to the origin, becomes odd. This is equal to that. This is considered positive, this area. This is considered negative. They cancel each other, becomes zero. Because remember, this represents the difference of areas. Definite integral represents the difference of areas for any function. On the other hand, if f is even, f of minus x equals f of x, then the integral of minus a to a f of x dx is 2 times the integral of 0 to a f of x dx. Now, what is the advantage of that? It is easier to use 0 when you evaluate rather than any number. That's why it's truly helpful. Take a look. It's an example of a case that is has an even symmetry. That means symmetric with respect to the y-axis. The left and right are the same, and therefore the left and right area, both of them are identical. And if they are identical, you instead of going from minus a to a, you can go from 0 to a and then multiply it by 2. So you're going to look at this function, and we notice this has degree even, but this has um, uh, no degree, which means also degree even. It's 0, everybody. And so no matter what, we are going to evaluate f of minus x. If I evaluate f of minus x for this function, becomes minus x to the power of 6, and which is x to the power of 6, and plus 1 doesn't change. So this is an even function. Instead of evaluating from negative 2 to 2, we're going to do it from 0 to 2, and we multiply it by 2. We're going to go with the bottom. So this is 1 over 7, x to the power of 7. This is x. And again, we could have gone with this and evaluated from negative 2 to 2. Don't have that one, but it's easier to go from 0 to 2 because you just plug in 2. The 0 gives you 0, so just plug in 2. So it's 2 to the power of 7 over 7 plus 2. 2 to the power of 7 is 128. 2, because this is 7, times 7. It's 14 over 7. 242. 142, my apologies. Times 2, 284 over 7. The integral of negative 1 to 1 tan x over 1 plus x squared plus x to the power 4 dx. When you get to a very complicated integral and it goes from minus a to a, you're hoping it ends up being an odd function and it becomes 0. So this becomes 0. Why is that? You have to show that this function, f of x, is this function. You have to show it's an odd function. We can't even integrate that, not with techniques of calculus. So what is f of minus x? This is tan of minus x, which becomes minus tan x. This doesn't change. This minus x quantity squared is the same. Minus x to the power 4, since they are even, it's the same. I hope you recognize that f of minus x, tan of minus x is minus tan x, and therefore f of minus x equals minus f of x. F of x is an odd function. We proved the function is odd, therefore the integral of minus a to a, more specifically from minus 1 to 1, f of x dx is 0 in this case. So a quick recap. When you take the integral from a negative number to a positive number, it's either odd or even. From negative to positive, same number, right? The opposite numbers. The lower limit and upper limit are opposite. Then the function is either even, so you make it from 0 to that number times 2, or odd, you really don't have to do anything. It's 0. All you have to do, prove it's an odd function. Okay. Evaluate the integral, and I want to have them next to each other, the integral of x sine of x squared and the integral of sine squared cosine x dx. Here's what happens when trigonometric functions are involved, sinusoidal functions, more specifically sine and cosine. If sine and cosine are involved and the argument has an exponent, that is the choice of u. We'll discuss the other one in a moment. So if u is x squared, the derivative is 2x, du is 2x dx. Again, we are going to rewrite things by moving the x next to the x. Everything is in order. What is missing is a number. Again, most texts, they solve for the x. I don't do that. I say 2 is missing. I'm going to put it in here. How do I undo it? With its reciprocal, 1/2. One might say, why is this inside? Why is this inside? Why is that outside? It doesn't make any difference. When you have a number, put it in or out. This one is inside because we need it. So it becomes half of the integral of sine u du. You know the derivative of sine is cosine. The integral is negative cosine. So negative 1/2 cosine u plus a constant. And the u is replaced with x squared. And we are done. Needless to say, if you differentiate the result, you should get this one without the dx. What about part B? What is the difference? In part A, the exponent, the argument x has the exponent. In this case, one of them has the exponent, either sine or cosine. When sine and cosine are involved, the one with the exponent is a choice of u, of course, without the exponent. So u is sine x. And what is the derivative of sine x? Cosine x. So what is du? Cosine x dx. So there's really not much you have to do. This is u squared. This is du. And according to power rule, this is 1/3 u cubed plus a constant. And so 1/3 sine cubed x plus a constant. And we're done. All you have to do, differentiate the result. You'll see the answer is this one without the dx. Now, just to make sure we understand that, I'm going to put this one where cosine has the exponent this time. So the cosine has the exponent this time. Well, that is the choice of u, everybody. So what is the derivative of cosine? Negative sine. What is du? Negative sine x dx. So just, I want you to notice this one is this except -1 is missing. So you put a negative here, you put a negative out. So in essence, this one needs a negative, so you put it there. And now clearly you have this negative and you keep it. And this is u to the power of 20 du. So -1/21, u to the power of 21, and a constant. Replace the u, and you're done. -1/21 cosine to the power of 21x plus a constant. So the argument has the exponent, that is the choice of u. Sine has the exponent, that is the choice of u. Cosine has the exponent, that is the choice of u. That's how it works. An application problem, breathing. We can model the rate of airflow into the lungs by the function f of t equals half of sine of 2 power over 5 t liters per second, where t is the time in seconds. Find the total amount of air inhaled in one cycle, known as the tidal volume, if the cycle lasts 5 seconds. Note the time for inhalation is half of the cycle, so 5 halves seconds, because this is 5 seconds. In other words, in and out, we are assuming they are identical, so half of that. That's why 5 halves, in and out. Total amount of air is the following integral, the integral of 0 to 5 halves f of t dt, which is 0 to 5 halves, and you put this function here. So we are going to integrate from 0 to 5 halves, half of sine of 2 power over 5 t dt. It's fairly simple. U substitution. You're dealing with a sine function, so you let u be this piece. U is 2 power over 5 times t. If I differentiate it, I get 2 power over 5. Therefore, du is 2 power over 5 dt. So again, I'm going to rewrite this, and I'm going to put the 1/2 out. Not that you have to, I just want it to be out of the way so it'll be clear what we have. We have sine of 2 power over 5t and then dt. So everything is in order except 2 power over 5 is missing, everybody. So that's not good. But 2 power over 5 is just a number. Because 2 power over 5 is some number, again, you can replace the pi with 3.14159. It's an approximation, so this is exact. I can put the 2 pi over 5 in, and I get what I'm looking for. So if I put 2 pi over 5 here, its reciprocal is 5 over 2 pi. I have to put it outside. So I'm going to put both of them. Again, product of these two must be 1. So these two, 5 over 4 pi. This one, sine of u du, and I'm not going to write the new limits yet. I'm going to write it in a moment. So again, can finish the job, go back to the original variable t and original limits 0 and 5 halves, or I can change the limits as we speak, and here's how I'm going to do that. If I put the 0 here, the lower limit remains as 0. If I put the 5 halves here, I get 2 pi over 5 times 5 halves. And that is pi. So the upper limit is pi. The derivative of sine is cosine. The integral is negative cosine. The new limits from 0 to pi. So 5 over 4 pi times minus cosine u from 0 to pi. I'm going to put this negative sign out. I make it minus 5 over 4 pi. Cosine of pi minus cosine of 0. Cosine of pi is minus 1. Minus cosine of 0 is positive 1. So minus 1 and minus 1 is negative 2. Negative 2 and negative 5, positive 10. Over 4, it's 5 halves. So 5 over 2 pi, precisely, roughly 0.796, and about 0.80 liters. It depends on how many decimals they ask you. If they don't ask, you have to answer in this format, 5 over pi, which is the exact answer, everybody. What is the integral of tan x dx? We don't know. What do? We rewrite it as sine over cosine. Now, whenever you have a fractional format, the first step is to simplify. When you can't, the denominator is a choice of you. So if u is cosine, du is, the derivative is negative sine x. Du is negative sine x, dx. So we are going to rewrite it. So tan x is 1 over cosine x times sine x dx. But we need a negative, it's missing. So negative means negative 1. So you put a negative in, negative out. That means you're putting negative 1 in, negative 1 out. Their product is positive 1 and it's fine. Therefore, we have minus the integral of this is du over u. 1 over u times du or du over u, which is a natural log. So minus natural log of u plus a constant, and you replace it with cosine. Now, I can put the negative in the following manner, just reminding you of log x base a to the power of n. You can put the n in front, okay? Or back and forth, right? So I can put this up here, and I get it ln of cosine x to the power of negative 1. Cosine x to the power of negative 1 is 1 over cosine, which is a secant x. So ln of absolute value of secant x plus a constant. So a quick recap, everybody. We haven't dealt with the integral of tan. We write it as a sine over cosine. The denominator is a choice of u. Du is almost the numerator, just the number negative 1 is missing. You make it up. And you end up with minus ln of u or minus ln of cosine x plus a constant. And this negative, when you put it here, becomes 1 over cosine, which is secant x. So the integral of tan x dx is ln of absolute value of secant x plus a constant. Section 6.1, the area of the region between two curves. Let f and g be continuous functions with f of x larger than or equal to g of x over the interval of a to b. Then the area of the region between the two curves from x equals a to x equals b is. And before we go that, I want to remind you of this Riemann sum. The limit of n going to infinity from I from 1 to n of f of x of I delta x is the definite integral of a to b f of x dx. Delta x is b minus a over n, x of I is a plus I delta x. So it's this integral, and of course, if it's a positive function. Remember, from a to b, f is at top, f is larger. Okay, doesn't matter what happens beyond the given interval. Okay, so area of region between f and g. Area of the region under f, this one. Area of the region under G, the red one. So the green one, completely below F, the red one, completely below G, and the difference between the two is this area under F is the integral of a to b f of x dx minus the integral of a to b g of x dx. So it ultimately becomes what you're looking at, everybody. Okay. So what does that mean? I want to make sure that, we can handle this as we go through the process. So we have two functions. One is completely above the other, and we want to evaluate the area between the two from two. Okay. So what do we do? The area of the region between the two curves, here's the process. Number one, graph the two functions. Number two, find the points of intersection. If they have points of intersection, you want to find them. How do you find them? By setting f equals g or f of x equals g and solve. And now that you have points of integration, you can evaluate the integrals because it gives you an idea what the limits are. So this is called a typical rectangle, the typical uh, rectangle that represents an increment of an area. Okay. This has some height. In this case, the height is f of x minus g of x. And it has some width. Of course, this is blown up out of the proportion for the sake of understanding and observation, but this width is extremely small. We call it dh. Now that, depending upon whether we move this rectangle along the x-axis, then becomes dx, or if it's this way, up and down, becomes dy. So the area of a typical rectangle is y of the t, y of the top, minus y of the b, y of the bottom. This is y of the top. This is the top, comes from the f function. This is the bottom, comes from the g function according to this graph. And the equation dA, dA stands for the increment of the area. For this rectangle is what? The width times the height. So h times dh. So that's for this piece. Now, as we go from a to b, then we evaluate the integral from a to b, h dh. Now, what is h? H is either y of the top minus y of the bottom, or if it's going this way, is x of the right minus x of the left. It depends. And if we are dealing with functions f and g, the integral of a to b f of x minus g of x dx. And again, we are going to make some sense out of this by looking at some examples. All right. Find the area of the region bounded by y equals 2x squared minus 3x plus 2. The x-axis, x equals 0 and x equals 2. First of all, this is a parabola. I'm going to assume everybody can graph it. For the sake of argument, the way you graph a parabola, you find the vertex, it opens up or down. And if need be, you find the intercepts, you have the graph. And, the vertex x equals minus b over 2a, y plug in. So first and foremost, you're going to graph this, and I'm assuming you have no problem with that. Of course, 2 is positive, it opens up. Because we want it to be between the x-axis, x equals 0, that means the y-axis. And x equals 2, it means we want this region, everybody. So all you have to do, find an increment of area. So And this is, by the way, the vertex. An increment of area, this, again, it's very thin, class. This has a height, and this has a thickness, okay? dA is H, dH, and it's Y of the top. Y of T is top, everybody. Minus Y of the bottom. The top is the function Y equals f of x, the parabola, and the bottom is the x-axis, Y equals 0. So this is f minus 0, everybody. This distance is f. So this point comes from the function. This point comes from the x-axis, f minus 0. So this function minus 0. And so you replace the y of the top with that, minus y of the bottom becomes basically this. So the integral of h dh becomes the integral of this one from 0 to 2. Very straightforward, everybody. So the hardest part is to figure out really what is y of the top, y of the bottom, and are you going to go, when it's dh, are you going to go for dx or dy? Again, class, dx, this thickness is dx, and it's going along the, you sweep this along the x-axis. So this is 2/3 x cubed minus 3/2 x squared plus 2x plus from 0 to 2. 0 doesn't do anything. Plug in 2. 16/3 minus 6 plus 4. I'm going to assume everybody can add them up. This is obviously minus 2. Okay. Which means minus 6/3. So they add up to 10/3 precisely. A quick recap. First, you have to graph. Then you look at the region that you want. Because the function is completely at top, then you go with y of the top minus y of the bottom. And dh becomes dx. Okay, if it's completely on the right, it's a different story. Sometimes we have to go with this, sometimes we have to go with that, sometimes both of them can be used. Find the area of the region bounded by this graph f of x equals 2 minus x squared. It's a parabola that opens down and goes up by 2, and the line g of x equals x. So first, you can easily graph the two. This is f of x, 2 minus x squared, and this is g of x equals x or y equals x. So as you can see, we need to find points of intersection. So we are going to look at the fact that this function is completely above this function. By the way, let me just draw this. I want to make a point. You can't use this one. Okay, here you can, but okay, this is okay because the right side is one function, the left side is a different function, but this one you can't because left and right are the same function, the curve parabola. So this has to be the case. So I'm going to erase my work. So this is the region we want, shaded region. And so first we want to set f of x equals g of x. So 2 minus x squared equals x. And because we want to solve this, we're going to take everything to the right because we want this one to be positive. So it becomes x squared plus x minus 2. And we do that because when we factor it, we want two numbers, the product is -2, the sum is +1, would be 2 and -1. And so x is either -2 or +1. The point being, you can do this fairly fast, everybody. Okay. So we get points of intersection. And so it's easier to use this one. G of x the same as x. So -2, -2, 1, 1. And of course, you really should check it with this. So those are the two pairs. So along the x-axis, we're going to go from -2 to 1. Along the y-axis, we happen to go from -2 to 1 also. But as I mentioned, if we look at this one, the top comes from the curve F. The bottom comes from the line G. So H is F minus G, and dA is y of the top minus y of the bottom times dx. This thickness, dx, because you're going to move this this way and that way. That means along the x-axis, you're going to sweep it to cover this. So think about this. You move it to the left. So y of the top, 2 minus x squared, minus y of the bottom, x. And we are going to integrate this from x equals -2 to y equals 1. So what do we have here? 2x minus 1/3 x cubed minus 1/2 x squared from -2 to 1. And I'm going to leave it for you to evaluate it and show that it's 9/2. Again, just plug in 1, plug in -2. That's elementary algebra. Find the area of the region bounded by the graph of x equals 3 minus y squared and y equals x minus 1. So I hope you remember that this is a parabola that opens sideways, more specifically because it's negative, it opens to the left. Okay. Y equals x minus 1 is just a line. So I'm assuming no one has any problem graphing the two functions. This is the parabola. X equals 3 minus y squared opens to the left. 3 minus y squared opens to the left. And we change this to x equals y plus 1. It doesn't change the graph of the line y equals x minus 1 is that. And the reason we change it to x equals y plus 1 because we have clearly one of the functions, which is the curve, on the right side of the other function, which is a line. So if I go up and down, over here is fine, over here is fine, but over here, up and down, both of them hit the curve. So we have to go left to right. In other words, this way. And so obviously, the first thing first is to set them equal to find points of intersection. 3 minus y squared equals y plus 1. So we take everything to the right because this is negative, becomes positive. Y squared plus y, subtract 3 from 1, you get -2. Again, you want two numbers. The product is -2. The sum is +1, -1, and 2. So we should have no problem factoring. Y is 1. Y is -2. So let's plug in 1. It's easier to plug it in here. Okay. If y is 1, X must be 2. So plug in 1. Y is 1. This must be 2. Plug in -2. -2, then this must be -1. And verify it with this one. So those are the two pairs, everybody. So here's a typical rectangle. The width is dy. The height is the function on the right, which is the curve, minus the function on the left, which is the line. Now the curve x equals 3 minus y squared, we're going to call it g of y equals 3 minus y squared. And the line x equals y plus 1, we're going to call it f of y equals y plus 1. So dA is x of the right minus x of the left times dy, which is g minus f dy. So what is g? 3 minus y squared. What is y? Y plus 1. What are the limits? The limits of the y from -2 to +1. So 3 minus y squared minus y plus 1 dy. And we go from -2 to 1. All right. So first let's rewrite this as minus y squared minus y 3. Just so this is minus y minus 1, and that gives us plus 2. So this is -1/3 y cubed, -1/2 y squared, plus 2y, evaluated from -2 to 1. Means plug in 1 gives you a number. Plug in -2 gives you a number. Their difference, 9/2. Okay, a quick recap. When we graph these two, this one clearly is a parabola that opens to the left. This one is a line, and because we have to go with this format, because one graph is completely on the right of the next one, the line, which is y equals x minus 1, we change it to x equals y plus 1. Just the same thing, okay? X, and the rest follows. You come up with their point of intersection and then evaluate. All right. Find the area of the region that is bounded by these two graphs. F of x is a line, and g of x is x squared plus 1. Y equals x squared is a parabola, shoots up by 1. So we want to graph the two functions. We want to find points of intersection, and that means set them equal. So I can get rid of the 1 and say x squared minus 2x equal to 0. I factor the x out. and I get two answers, 0 or 2. And now I'm going to say, okay, when x is 0, if x is 0, it's 1. So 0. When it's 2, 4, and 1, 5. And again, it's important to know that you really have to check it. If you check it with this one, you see the same thing. Now, the next step is to evaluate an integral, but what integral? Well, let's come up with a typical increment of an area. Typical area, you see that the line is completely above the curve, so we're going to go with dA is h dh, and we're going to go with y of the top minus y of the bottom. And the top is the function that is 2x plus 1, and the bottom is the function that is x squared plus 1. So we are going to write 2x plus 1 minus x squared plus 1, and then dx. That's dA. And to evaluate the integral of a to b y of top minus y of the bottom dx, we write this, and the bottom is, we are talking about the x 0 to x2, from 0 to 2. I hope you see that these two cancel each other. This gives us half of x squared. This 2x gives us, my apologies, x squared, and this gives us minus 1/3 x cubed. We plug 0 and 2, and the answer is 4/3. And we are done. But what is interesting is that we can actually do it with a second method. Notice if I draw this, the curve is completely on the right side of the line. And when I say completely, I mean from the beginning to the end. Therefore, I can use the second method, which means I'm going to use x up right minus x up left dy. Okay. So I'm going to write f of x and g of x. So this is g minus f, and we're going to figure out, how we come up with that. First, here's the function. F of x is y equals 2x plus 1. So I'm going to solve for x. Here's g of x, or y, x squared plus 1. I'm going to solve for x. This one is half of y minus 1. Just move the 1 and divide by 2. This one has two answers. Plus, this has two answers, plus minus the square root of y minus 1. The right side is positive. This side is minus. This side is minus square root of y minus 1, because on the right, we're going to use this one. We've already figured out points of intersection. So x up the right comes from the curve, square root of y minus 1, minus x up the left comes from the line, and then we put dy, and we're going to evaluate it from the y coordinate to y coordinate, from 1 to 5. So I hope you see that the first method is easier, but just wanted to let you know that it is possible to go that far. Now quickly, this is y minus 1 to the power of 1/2. And I'm going to leave it for you to show that this can be done by the method of substitution. You let you represent y minus 1, and du is dy. So this becomes 1 over 1/2 plus 1, u to the power of 1/2 plus 1, and it 1 over 1/2 plus 1, or 3/2 becomes 2/3. So this becomes 2/3 y minus 1 to the power of 3/2, and this one is 1/2 times half of y squared minus 1, y from 1 to 5. You just plug in 2/3, 4 to the power of 3/2, and minus 1/2 to the power of 25 halves minus 5, 2/3 times 0. power of 3 halves. And this one, of course, quickly, this is 0. Minus 1 half minus 1 half is 1/4. 4 to the power of 3 halves, that means square root of 4, 2 cube. 8 times 2, 16/3. 25 halves minus 5 or 10 halves. This is 15 halves. So we have 2/3 times 8, 16/3 minus 1 half and 15 halves minus 15/4 minus 1/4. They add up to 16/12 or 4/3. They are the same. This was easier to calculate. So a quick recap. If we want to go from the bottom to the top is the line, the bottom is the graph of the curve, we can do that. If we go from left to right, the right side is the curve, the left side is the line, we can do that. So both methods are done, so you can see it for practice. The last question, find the area of the region for f of x and g of x. First and foremost, you have to graph. Now, the reason I chose this, again, to show you that sometimes one is at top, sometimes the other one, okay? So this is the function, which is the cube function. This is the parabola, okay? So parabola is at top for this portion, is at the bottom for this portion. That's the idea. We want to, so that's the function 3x cubed minus x cubed plus minus 10x, and this is the g of x. So we have to set them equal. So we move everything to the other side. And to do that, first and foremost, quickly, I'm going to drop these two because they are identical. When I move it this way, I get minus 12x. I can take the 3x out. And there are three answers. X is either 0 or plus minus 2. So there are three answers. So therefore, points of intersection. And what you do, you put them into either G or F, in fact, into both of them to double check, and we get the following pairs. This is -2, -8. This is 0, 0. This is 2, 0. And we evaluate the integral, noticing that it's y of the top minus y of the bottom times dx, because in each case, one is at top of the other. So in this case, it's f minus g. In this case, is g minus f. So this part is f minus g. So this part, from the x coordinate minus 2 to x coordinate 0, the cube function is at top. Okay, so the difference of the two is 3x cubed minus 12x dx. But for the next part, from 0 to 2, the parabola is at top. So you are going to subtract this one from this one, so you get the opposite of that. Okay, this one is g minus f. So from 0 to 2, you have minus 3x cubed plus 12x dx. So this is 3/4 x to the power of 4 minus 6x squared from minus 2 to 0. This is brackets, parentheses, minus 3/4 x to the power of 4 plus 6x squared from 0 to 2. And I'm going to leave it for you to evaluate and verify. You end up with 24 as the final answer.